G'day team, welcome back to another video. So in this one we are going to be extending our trigonometric ideas into radian measure. We're going to be looking at the unit circle and developing that, alright? So we do need to actually take it back a step and actually define what radian measure is. So if you're playing along with the Hazy textbook, we're looking at chapter 5a today in the 11 methods textbook. So previously, when we've been working with circles and angles, we've measured angles using degrees, where 1 degree is 1/360th of one full revolution, because there's 360 degrees in a circle. But this is just an arbitrary number, okay? So a more natural way to measure an angle is to compare the length of the arc formed by an angle with the radius of a circle. All right, I'll show a diagram of that in a second. And we call this idea radians. So in my brackets here, I've got 1 radian. So like in degrees, we put the little circle. With radians, we put the little C up the top there. We often won't actually write this in, but it's good to start with this. So, like I said, 1 radian is the arc length, okay, of the angle made from the radius, okay? So over here, please note that the radius here is the same length as this arc here, so that's why they're both called R. If the arc length is twice as long as the radius, so remember the arc length is the big curved length. If it's twice as long as the radius, then the angle has a measure of 2 radians, okay? That's how we denote this. So 1 radian is actually approximately equal to 57.3 degrees. So if we're looking over to this diagram here, we can actually see that 1 radian is just slightly smaller. If I zoom in a bit more, you can see it's slightly smaller than our 60 degrees, okay? So 1 radian is actually 57.3 degrees approximately. And we've actually defined pi radians to be 180 degrees. So the 3-pronged equal signs means defined to be. So pi radians is defined to be 180 degrees. Okay, so we've got our little radius here, arc length of pi times by the radius. So that's 180 degrees or pi radians. That is one key thing to remember, all right? So 1 radian is equal to 180 degrees divided by pi, which is approximately 57.3 degrees, like we said before. But if we reverse that, 1 degree is equal to pi on 180, so pi divided by 180. See how we've done the inverse of the fraction there? So it's pi divided by 180 degree radians, which is approximately equal to 0.0175 radians. Okay, so this is a really cool little flow chart that you guys should write down, because this is what we're going to be using for these questions. So if we want to convert from degrees to radians, we times the degrees by pi over 180, pi divided by 180. And if we're going from radians to degrees, we times by 180 divided by pi. Okay, so what happens, degrees to radians, we're going to put our degrees in terms of pi. And from radians to degrees, we're going to take out that factor of pi by dividing through by pi. Okay, so please make note of this flowchart, because that's going to be super duper helpful when we start cracking through questions. All right, so just a few questions we can run through. So we're going to convert the following to radians. So hopefully you remember that converting to radians, we're going to be timesing by pi on 180. All right, so all we're doing is going 30 times by pi over 180, which equals pi on 6. So we want our radians to be in terms of pi if we can, all right? So a lot of the time you'll be able to simplify the two numbers, but we want to keep pi's involved, okay? That's our number 1 goal. So B, 195 times by pi over 180, okay? So if you're playing along at home, grab your calculator out. So that's what I'm doing right now, times by pi all over 180. So that's actually equal to 13 pi on 12. And your calculator should keep it in this form. Okay, part C, take that same equation and substitute in 320, and that comes out to be 16 pi on 9. And then D, 270 times by pi over 180 actually gives us 3 pi on 2. All right, so that's another pretty key one that you'll use a fair bit when it comes to the unit circle as well. So example 2, so convert the following to degrees. So we're going to be timesing by 180 over pi. All right, so A will have pi on 6 times by 180 over pi. The 2 pi's cancel out, so we're left with 180 over 6, which equals our 30 degrees, same as before. Okay, B, I'll just do B, I won't do C and D. You guys can do C and D if you feel like. So pi on 2 times by 180 over pi. Again, the pi's cancel out to be 1. 180 over 2, which equals 90 degrees. So pi on 2 radians equals 90 degrees. All right, so it's a simple conversion. If you can, all you have to remember is which way this fraction goes. Remember, if we're converting to degrees, the pi is on the bottom. If we're converting to radians, the pi is on the top. All right, so if you are playing along at home, have a crack at the following questions in 5A. All right, so question 1, odds. Question 2, ACE. Question 3, odds. Question 4, ACE. Question 5 and 6. All right, so that should get us on a nice start for the rest of this topic, and we'll see